Dear students, let's see this question. He's saying that a cylindrical furnace of height h and diameter d, both 1 meter, Here is given, this height is given as h, h is given, diameter d, both 1 meter. It is maintained at a temperature 360 Kelvin. Maintained at a temperature 360 Kelvin. So here how much temperature is there? 360 Kelvin is there. The air gets heated inside the furnace at constant pressure PA. So in the furnace means this one. So in the furnace, what will be the pressure? The pressure is maintained constant and it is PA. So inside the furnace, pressure is PA and temperature is 360 Kelvin. So now see here, furnace at constant pressure PA and this temperature becomes 360. The hot air with density rho rises up with vertical chimney of diameter d. So here, when the air becomes hot, then the hot air raises up. So here the density how much is given? It is rho is given. Density how much it is? Rho. This density or this air will go up along the chimney. Diameter is given, d is equal to 0.1 and height is given, height is equal to 9 meter. So this chimney height is equal to 9 meter is given. And he is saying that as a result, atmospheric air density rho A 1.2 kg per meter cube, pressure PA and temperature TA which is equal to 300 Kelvin enters the furnace. That means here air is entered here. It is furnace, right? Furnace. That means a device where we can heat the air. So air is entered in this direction. Air is entered. So here, if you see this situation, for this air, the pressure is given as PA. Pressure is how much? PA. Temperature is given as 300. Temperature is 300. When this air having a pressure PA and temperature 300, when it is entered into the furnace, so pressure is remaining constant and temperature becomes 360. Temperature becomes 360 by keeping the pressure is constant. And he is saying that ignore the viscous force, find the following. So here there is no viscous drag, there is no viscous force here. So what he is asking, find the following. Here two questions are there. So we will try to understand. Easy only, no need to worry. Right? So again I am explaining. Here a furnace is there. The furnace is maintained. Furnace means only this one only. This box. Right? It is only maintained at pressure PA, temperature 360. Air is entered. Air is entered into the furnace. Air is having the pressure PA and temperature 300. So when air is entered into the furnace, pressure becomes PA, temperature becomes 360. When then automatically the density of air changes, that air will blow up. And based on this question, based on this concept, here two questions are there. We will try to understand one by one. See here, first question, what is asking? Considering the airflow to be streamline. Flow. When he is saying that it is streamline flow, he is given that we can apply Bernoulli's principle, right? And he is saying that the steady mass flow rate of the air exiting the chimney is. So he is asking that steady mass flow rate he is asking. So first we will try to understand what is the meaning of steady mass flow rate. So after that we will go with the diagram. Clear? So he is asking that steady mass flow rate, which means dm by dt. What he is asking? He is asking dm by dt. First we will try to understand how to calculate dm by dt. We know that, I will write here, we know that according to equation of continuity, the rate of flow of volume of liquid remains constant. The rate of volume of liquid through a tube remains constant. The rate of volume of liquid, which means d volume by dt, is equal to A1 V1, which is equal to A2 V2. So here generally we know that from equation of continuity, of continuity d volume by dt is equal to AV. d volume by dt is equal to AV. Area and V is velocity. Area and V is velocity. Here volume is there. So how to write? We know that density is equal to mass upon volume. Mass is equal to, volume is equal to mass upon density. So I will write here dm by dt into rho, which is equal to AV. So dm by dt is equal to rho AV. What is dm by dt? dm by dt is equal to rho AV. So he is asking that the steady mass flow rate. The steady mass flow rate is nothing but rho AV. So dm by dt is nothing but rho AV. So these values you have to calculate and you have to find out dm by dt. I hope you understood, right, what we are calculating. So here I will arrange these points. See here, now we understood that what we are going to calculate. We are going to calculate dm by dt, which is nothing but rho AV. Now we will see here. Here in this situation, try to understand the diagram. Easy only. In this situation here, just see, I will draw like this. So one thing we have to understand, inside the furnace pressure remains constant. That means here it is PA, and we know air entered in. How much pressure is there? Here also it is PA. Clear? And here temperature is 300 is given. Here temperature is 300 Kelvin. Density is rho A. When it is entered, here temperature is 360. So density I have to calculate. First, what I want to calculate? I want to calculate density. So now see here how to calculate density. We know that PV is equal to N. PV is equal to nRT. So for n number of moles, 1 number of mole. So I will write PV is equal to RT. We know that density is equal to mass upon volume. Volume is nothing but mass upon density. So P, volume is nothing but mass upon density, which is equal to RT. I wrote PM is equal to rho RT. So here pressure, mass remains constant, and again rho R is constant. So I will write there P proportional to rho T. P proportional to rho T. Clear? Now in this situation, try to understand here. P proportional to rho T means I will write here P1 by P2 is equal to rho 1 T1 by rho 2 T2. P1 by P2 is equal to rho 1 T1 by rho 2 T2. So here P1, so at this point pressure, before the furnace, what is pressure here? PA. And inside the furnace, again pressure is PA. And outside the furnace, density is rho A. And temperature is 300. Upon inside, density we don't know, we have to calculate. And temperature is given as 360. So PA get cancelled. So I will write here rho is equal to how much we will get? Rho A is already given 1.2 into 300 by 360. So rho is equal to, so here 12 into 30 by 360. So rho is equal to 360 by 360, which is equal to 1 kg per meter cube. 1 kg per meter. That means inside the furnace, when it is heated up, when air is heated up, the density changes. How much it is? Density is equal to 1 kg per meter cube. That means the air is flowing in this direction, or air is flowing into the furnace from the to the pipe. How much it is density? Density is equal to rho, which is equal to 1. Here I will write here rho is equal to 1 kg per meter cube. I got this one. Clear? Again try to understand. Our target is to find dm by dt. See here. So now consider this situation again. Tube is this one. And now this is the situation. Now I'm not going to think about this one, but because we already calculated in this region what are the values are there, we calculated. Now just imagine I consider 2 points, 1 point this one and 1 point this one. 1 point this one and 1 point this one. Just imagine. Here I will write pressure is given as PA, already we know. Here pressure I don't know. Pressure I don't know. So I want to calculate the pressure here. And at this point density is given as rho is given. Density, sorry, here it is rho A and here it becomes it is rho density. Correct? Correct? Now try to understand, apply Bernoulli's equation. Apply Bernoulli's principle or equation can write. So at this point we will write PA. We know according to Bernoulli's equation, pressure plus P plus half rho V square plus rho GH is equal to constant. P plus half rho V square plus rho GH is equal to constant. So I am considering this is a reference line. So P plus PA plus half rho V square, So at this point we are considering the velocity is 0. Velocity is 0. So it is 0 plus, again at this point it is a reference line. Thus the height is also 0, which is equal to, at this point I want to calculate the pressure. So at this point I want to calculate. So pressure at this point, for example, let it be A and here let it be B. So I want to calculate the pressure at this point. So how to calculate? A very important point this one. Try to understand. How to calculate the pressure at this point? At this point I know the pressure PA. But because he is saying that outside and inside the pressure maintained constant. So here it is PA. So when I want to calculate the pressure at this point, right? So if I want to calculate pressure at this point, try to understand, I'm going up. So at this point, how much pressure will be there? When I went up, the pressure will increase or reduces? Pressure is increasing or decreasing? Pressure is decreases. So I will write at this point, pressure will be PA minus rho GH. Clear? Again from this point, I am going down. How much height it is? Height is H is given. So at this point, the pressure will be PA minus rho AGH plus rho GH. I hope you understood, right? Again, I am explaining, try to understand. For example, here one point is there. From this point, if you are moving upward, the pressure is reduces. When we are going down, the pressure is increases. The same concept I am applying here. From here, I don't know the point at this point pressure. So from here, I am moving up. So pressure reduces. Again, moving down, pressure increases. So first I calculated the pressure at this point. So pressure at this point is height H is decreases. So pressure is decreased by rho A GH. And again height H is increases in a density rho. Thus the pressure is increases by rho GH. So at this point I will write at this point pressure all I got at this point pressure PA minus rho A GH plus rho GH plus half rho V square. Half rho V square. Again, there is no matter of height. In between these 2 points, there is no height, right? So directly I will write half rho V square. From this, I will find the value of V, and after I will substitute here, I will get the answer. So see here, I will write. So here we will write here PA is equal to PA minus rho A GH plus rho GH plus half rho V square. So here PA get cancelled. So here half rho V square can be written as I will write here. Try to understand. Half rho V square can be written as this becomes plus and this becomes minus. So here it is rho A GH minus rho GH. So half rho V square can be written as here rho A minus rho into GH. So substitute the values. Half rho I got 1 into V square, which is equal to rho A. Rho A is given as 1.2. Rho A is how much? 1.2 minus rho is nothing but 1 into G into H. So here it is. I will write V square by 2 is equal to 1.2 minus 1, 0.2. So 0.2 into G is 10 and height is how much it is? Height is 9 is given. So I will write 9 here. So we will write here V square by 2 is equal to how much you will get? 2 into 9, 2 into 9, it is 18. So here V square is equal to 36. So V is equal to 6 meter per second. How much I got? V is equal to 6 meter per second. Now what we are going to calculate? He is not asking the velocity. So with this velocity, the air is moving out and it is coming out. Correct? For example, in the question he is asking that with what velocity the air is coming out. So you can write simply V is equal to 6 meter per second. But he is asking the dm by dt. What is dm by dt? Dm by dt is nothing but rho A V. Now see here. Now see here. See, rho already we know it is 1 area pi r square into V. Velocity is how much? 6. So it is pi. What is r? This d is given. D is given. How much it is? 0.1. So d is given 0.1. So radius you can find it is d by 2. So here I will write 0.1 by 2 whole square into 6. So we write here pi into 0.1 into 0.1 by 4 into 6. So here it is 3.14 into here 10 power minus 12 right into 6 by 4. 3.14 into 10 power minus 2 into 6 by 4. So I will write here. So we will get here dm by dt is equal to dm by dt is equal to how much we will get here? We will get here 3.14 into 4. 4 ones are 4. 2 is remaining 4 5s 1.5 right into 10 power minus 2 right, and again here dm by dt. So here we have to multiply here. If you multiply, just try to understand, find the multiplication and substitute there here. See here, here 3.14 into 1.5. So here 4.71 into 10 power minus 2. So this one will be kg per second, but answer is saying in grams. So I want to write here dm by dt, which is equal to 4.71 into 10 power minus 2 into 10 power 3. So we know how to convert. So here we will write 4.71 into 10, 47.1 gram per second. So dm by dt. dm by dt is equal to 47.1 gram per second. I hope you understood, right? Clear? Just please make a note and we will go with the second one. See, based on the same concept, the second question, if you see here, when the chimney is closed using a cap at the top, chimney is closed using a cap. That means here chimney is there, na? Here this one. Now what he did? He closed. For example, here he put one cap and it is closed. Clear? And see here, a pressure difference delta P develops between the top and bottom surface. Then automatically there will be some pressure difference is there between the top and the bottom surface. And he's saying that if the changes in the temperature and the density of the hot air due to the stoppage of air are negligible, then find the delta P. That means by stopping the air, there is no change in the temperature and no change in the density. And what he's asking? He's asking that find delta P is asking. See here how to solve this one. Here, just see, we'll try to understand. Again, this one also very easy. Try to understand. Here, this one, the point is this one, and again here it is closed. And height is given as this one is h. And here outside the pipe is rho A, and this one is rho density. Clear? Now see here, at this point I don't know, let it is P1. At this point I will write it is P2. So I want to calculate the pressure difference. I want to calculate the pressure difference. Pressure difference generally here P2 minus P1. P2 will be greater pressure. Why? Because here air is heating, right? So here P2 will be greater than the P1. So now see how I will calculate. See here, we will try to understand. From here I will go. From here I will go. See, here it is P1. Down I am going. So here density is rho A. So minus rho A G into H. So again I am going inside. So plus rho G H. Why? Because inside the pipe density is rho. Inside the pipe density is rho. That's why I wrote rho GH, which is equal to P2. Which is equal to P2. So you may ask questions of how you wrote this one. So by Pascal's law only I'm writing this equation, right? Again, if possible, I will explain. I will take one more class based on the Pascal's law. See here. Now he's asking pressure difference, right? Now see P2 minus P1, which is equal to P2 minus P1 calculated. We'll see. Now try to write the equation. Now we'll substitute the values and after we'll calculate the delta P, right? So here P1 minus rho A. What is rho A? 1.2 into G is 10, H is 9 plus rho inside air density is 1 into 10 into 9, which is equal to P2. So here P1 minus this one is 12, becomes 12 into 9 and plus this one is how much? 90, which is equal to P2. P1 minus 108 plus 90, which is equal to P2. So here it is how much it is? P1 can written as try to find. So here it is P1 minus 18, which is equal to P2. So P1 minus P2 is equal to 18. So here delta P, which is equal to 18 pascals. This will be the answer, right? So we'll try to understand again. So here P1 I wrote. Sir, you can solve from here also. You can solve. I will write P2. I'm going down. P2 minus rho GH. P2 minus rho GH. Again I am moving up. Rho GH, which is equal to P1. Like that also you can write. But both are remains same. So in this manner we can able to solve this question easily. I hope you understood, right? Thank you.